You know, in a world where artificial intelligence is creating this absolutely insatiable demand for power, a pretty surprising solution might be hiding in the heart of the Himalayas. So today, we're going to explore a really fascinating economic proposition. Can Nepal, a country with a surplus of clean energy, become the unlikely engine for Asia's entire AI revolution?
This quote just captures the central challenge perfectly. The AI industry has slammed into a wall, and it's not a silicon wall, it's made of copper wiring and power substations. So the new strategic imperative for every single major tech company is securing vast, stable, and, preferably, green sources of power.
And that brings us to the core of this whole thing. See, Nepal faces this weird paradox. During its wet season, it generates so much clean hydropower that a huge amount of it just goes to waste. So the critical question becomes, can Nepal transform that wasted energy into a valuable export? Not as raw electricity, but as something much more valuable, processed data.
To really get why this is such a big opportunity for Nepal, you first have to grasp the sheer scale of AI's energy appetite. I mean, a single high-end AI processor can use as much power as a small house. Now imagine a data center with thousands of them. We're talking about more electricity than a small city. This isn't just a trend, it's a global power crunch.
Okay, so let's look at the established hubs, right? In Virginia's famous data center alley, the grid is so overloaded that new connections are being pushed back for years. Singapore, they've put an outright ban on new data centers because of energy constraints. And in rising hubs like India, power isn't just expensive, it's often unreliable. This global bottleneck, well, it creates a massive strategic opening for a new player with power to spare.
And this is exactly where Nepal enters the picture. And it doesn't just have one advantage, it has two really powerful ones: abundant, low-cost hydropower and a naturally cool climate. This unique combination directly attacks the two single biggest operational costs of any data center.
Now, to understand why these advantages are so huge, we need to talk about a key metric in the data center world: total cost of ownership, or TCO. This isn't just the price tag for the building and the servers. No, it's the total cost to run that facility over its entire life. And for a data center, the biggest slice of that pie is always power.
And the impact of that power on the bottom line is just staggering. In a typical data center, power and cooling can eat up half of the total cost of ownership. But by offering power at less than 5 cents per kilowatt hour, a price that's pretty much unheard of in other major hubs, Nepal could slash that cost in half. That leads to a massive 20 to 25% reduction in the overall TCO. This isn't just a small discount, it's a game-changing structural advantage.
The second piece of this puzzle is cooling efficiency, and we measure that with a metric called power usage effectiveness, or PUE. So a perfect PUE score is 1.0. That would mean every single watt of electricity goes directly to the computers. Anything higher than 1.0 means you're just spending energy to keep the machines from overheating.
And this just perfectly illustrates Nepal's second advantage. A data center in a hot, humid city like Mumbai might have a PUE of 1.6, which means a huge chunk of its energy bill is just going to air conditioning. In contrast, a data center in the cool Himalayan foothills, it could use the outside air for cooling for most of the year, achieving a super efficient PUE of 1.2 or even less. This combination of cheap power and natural cooling, that is Nepal's unique selling proposition.
Okay, so there's an obvious objection we need to tackle head-on. I'm sure you're thinking it. Isn't Nepal just too far away from major markets? This is all about network latency.
And look, for tasks where every millisecond is critical, like online gaming or real-time video calls, the answer is yes. It's too remote. Trying to compete for those kinds of jobs would be a mistake. But the AI industry is not a monolith, and this is where the strategy gets really, really clever.
You can really divide AI workloads into two main buckets. First, you have those latency-sensitive tasks that need an immediate response. But then, there's this massive and fast-growing category of work called asynchronous compute. These are the huge, non-urgent jobs where the total cost to get the job done is way more important than a slight network delay.
Think about it. Training a large language model, that can take weeks. Or a pharma company screening millions of molecules for a new drug. Or an animation studio rendering a feature film. For these incredibly power-hungry tasks, the math is simple. Is it cheaper to run this job in Nepal? The latency becomes a rounding error. The cost savings absolutely do not. This is Nepal's strategic sweet spot.
So what does this actually look like in practice? Let's talk about a tangible model, something we can call the Dhalaka blueprint, which is centered around a major hydropower project.
This whole model is about vertical integration. You build a dedicated data center park, zoned as a special economic zone, right next to the hydropower plant. It gets a direct, high-voltage line, which minimizes any power loss. And right there, raw electrons are converted into high-value processed data, ready for export. You're not just selling power anymore. You're selling computation.
The economics are compelling. The model is clear. But there is one pretty significant hurdle that stands between this vision and actually making it happen.
Right now, Nepal is standing at a crossroads. The status quo is to just keep exporting raw electricity as a low-value commodity and let its neighbors capture all the value from the digital economy. The alternative is this green compute gambit, a strategic choice to capture that value at home by exporting finished processed data. To make this happen, global investors need policy clarity. That means a dedicated Digital Infrastructure Act. It means long-term power purchase agreements priced in US dollars to get rid of currency risk. And it means active government support for building out the fiber optic networks. The capital will show up if the framework is predictable and secure.
And really, this all brings us to the final, critical point. The challenge for Nepal isn't about finding the money or the technology to build these data centers. The real challenge is institutional will.
And here's the hard truth. While Nepal has a surplus of electrons flowing from its rivers, it has a serious deficit of photons. Its international fiber optic connectivity just isn't robust enough, redundant enough, or cheap enough to support the massive data flows that an AI hub would require. That right there is the single biggest risk for any investor.
So we're left with a really critical question. The opportunity for Nepal is immense. It's a chance to kind of bypass traditional development and plug directly into the heart of the AI economy. The natural resources are there, the economic case is strong. The final crucial piece of the puzzle is investment in those digital arteries that will connect Nepal's processing power to the global digital brain. And the decision to make that investment, well, that's what's going to shape the country's economic future.